Imagine every star you have ever seen in the night sky. Now, imagine them vanishing, one by one, like candles being snuffed out in a drafty room. Imagine the galaxies drifting so far apart that the space between them becomes a vast, impenetrable wall of darkness. This is not the plot of a science fiction film. This is the inevitable reality of the cosmos. Everything you see, everything you know, every atom in your body, and every mountain on this planet is heading toward an end. We often think of the universe as eternal, a constant backdrop to our fleeting lives. But the laws of physics tell a different story. The story of a universe that had a beginning, and most certainly will have a final chapter. To understand how it all ends, we have to understand how it is behaving right now. For billions of years, we believed the universe was a static place, or perhaps a place where gravity would eventually pull everything back together. But in the late 20th century, we discovered something that changed everything. The universe is not just expanding, it is accelerating. Galaxies are racing away from each other faster and faster every second. It is as if the fabric of space itself is being stretched by an invisible, mysterious force we call dark energy. This force makes up about 70% of everything in existence, and it is the primary driver of our cosmic destiny. It is the architect of the end. There are several theories about how this all plays out. The most widely accepted is the Big Freeze, also known as the heat death of the universe. It is a slow, agonizingly quiet departure. In this scenario, the expansion of the universe continues forever. As galaxies move further apart, the light from distant stars can no longer reach us. The night sky becomes emptier and emptier, until eventually our own galaxy is the only thing we can see. But even then, the clock is ticking. Stars are powered by nuclear fusion, burning through their limited supply of hydrogen. One by one, the lights go out. The massive blue stars die young and violently. The yellow stars, like our sun, swell into red giants before collapsing into white dwarfs. Finally, even the smallest, dimmest red dwarfs, which can live for trillions of years, run out of fuel. The universe enters the era of cosmic graveyards. It becomes populated by the remnants of dead suns, white dwarfs, neutron stars, and black holes. The temperature of the universe drops toward absolute zero. There is no more heat, no more light, and no more energy available to do work. This is the ultimate victory of entropy. Entropy is the measure of disorder, and the second law of thermodynamics dictates that it must always increase. In the Big Freeze, the universe reaches a state of maximum entropy. Everything is spread out so thinly and so evenly that nothing can ever happen again. Time itself loses its meaning because there are no events to mark its passing. It is a silent, frozen wasteland that lasts for an eternity of eternities. But what if dark energy behaves differently? What if it doesn't just stay constant, but grows stronger over time? This leads us to a much more violent end, known as the Big Rip. In this version of the future, the expansion of space becomes so powerful that it begins to overcome the forces that hold the universe together. At first, galaxies are pulled apart. Then, the gravity of individual stars is no longer enough to keep planets in orbit. The solar system dissolves. As the rip intensifies, the very planets themselves are torn asunder. But it doesn't stop there. The expansion becomes so fierce that it begins to act on the microscopic level. Molecules are ripped apart. Atoms are shredded. Finally, the fabric of space-time itself is torn to pieces. In the Big Rip, the universe doesn't just fade away, it is literally murdered by its own growth. Then, there is the possibility of the Big Crunch. This is a more traditional view of the end. where gravity eventually wins the tug of war against expansion. If there is enough matter in the universe, its collective gravitational pull might one day slow the expansion to a halt. For a brief moment, the universe would stand still, and then it would begin to collapse. Galaxies would start racing toward each other. The light from distant stars would be blue-shifted, becoming more energetic and hotter as the universe shrinks. As space gets smaller, the temperature rises. The cosmic microwave background radiation, currently just a few degrees above absolute zero, would heat up until it surpassed the temperature of stars. The sky would glow with an unbearable heat. Atoms would be stripped of their electrons, and stars would ignite the very space between them. Eventually, everything, every black hole, every atom, every bit of light would be crushed back into a single, infinitely dense point, a singularity, much like the one that started the Big Bang. Some scientists believe the Big Crunch isn't actually an end, but a transition. This is the Big Bounce theory. It suggests that once the universe collapses into a singularity, it might trigger another Big Bang, starting the cycle all over again. In this view, we live in a cyclic universe, one that breathes in and out over trillions of years. Every end is just a new beginning, and we are just one iteration in an infinite chain of cosmic rebirths. It is a comforting thought, the idea that the universe is immortal, even if we are not. However, there is a much more sudden and terrifying possibility called vacuum decay. To understand this, you have to think of the universe as having a fundamental energy level, like a ball sitting on a hill. We believe our universe is in a stable state, but it's possible we are actually in a false vacuum. This means we are like a ball sitting in a slight dip on the side of a mountain, rather than at the very bottom. If a quantum tunnel event were to occur anywhere in the universe, it could push a small bubble of space into a lower energy state, the true vacuum. This bubble would then expand at the speed of light, incinerating everything in its path. Because it moves at the speed of light, you would never see it coming. One moment you are sitting in your chair, and the next, the laws of physics themselves change, and every atom in your body is instantly dismantled. It would be the ultimate game over. A cosmic reset button, pressed without warning. As we look further into the deep future, beyond the life of stars, we encounter the black hole era, in a universe that has succumbed to the big freeze. Black holes become the dominant residents. They will roam the darkness, swallowing up the cold iron remains of stars and planets. They will grow to gargantuan sizes, becoming the last bastions of organized matter. But even black holes are not permanent. According to Stephen Hawking, black holes slowly leak radiation over unimaginable timescales, numbers so large they defy human comprehension. Black holes will lose mass. Slowly, they will shrink. Eventually, they will vanish in a final brilliant flash of gamma rays. Once the last black hole has evaporated, we enter the final stage, the dark era. This is a universe of nothing but stray photons and neutrinos, drifting through an infinite void. The particles are so far apart that they will never interact again. There is no structure. There is no heat. There is no light that can be seen by any eye. The universe becomes a graveyard of information, where every memory of every civilization, every star, and every atom has been erased by the relentless expansion of space. It is easy to feel small when contemplating these things. We live on a tiny rock orbiting a middle-aged star in a quiet corner of one galaxy among billions. Our entire history, from the first spark of life to the launch of the first satellite, is less than a blink in the eye of cosmic time. We are living in the stelliferous era, the age of stars. This is a brief, glowing moment in the history of the universe when it is vibrant, warm, and full of potential. We are lucky enough to exist at a time when the sky is full of light, and the laws of physics allow for the complexity of life. The end of the universe is not something to be feared in a human sense. It is billions, trillions, and even googles of years away. But understanding the end gives us a profound perspective on the present. It reminds us that change is the only true constant. It tells us that the structures we see, the galaxies, the stars, the planets, are temporary arrangements of matter and energy. They are beautiful, intricate, but ultimately fleeting. In the face of such overwhelming darkness, the fact that we can even ask these questions is a miracle. We are a way for the cosmos to know itself. We have used the power of logic, mathematics, and observation to peer into the deepest reaches of the past and the furthest points of the future. We have mapped the beginning of time and theorized its end. That a collection of atoms forged in the hearts of dying stars could rise up and contemplate the destiny of the entire universe is perhaps the most extraordinary thing of all. As we look up at the stars tonight, we should remember that they are not just points of light. They are the engines of creation, and their eventual disappearance is part of the grander narrative of the universe. The cosmos began in fire, and it may end in ice, or a rip, or a sudden collapse. But right now, it is alive. It is expanding. It is full of mysteries, waiting to be solved. We are part of a story that is still being written, a story of a universe that found a way to wake up and look at itself. And even if the final chapter is one of silence and darkness, the fact that there was a story at all is enough. Think about the scales involved once more. If the entire history of the universe were compressed into a single calendar year, the Big Bang happened at the first second of January 1st. Human history wouldn't even appear until the final seconds of December 31st. We are newcomers to a very old house. And yet, we have already figured out that the house has a foundation and a roof, and that one day the walls will crumble. We are the inhabitants of the Golden Age. We can see the cosmic microwave background, the afterglow of the Big Bang. We can see the galaxies before they disappear over the horizon of the observable universe. We are at the perfect vantage point in time. Future civilizations, if they exist trillions of years from now, will have a very different view of the cosmos. They will live in a universe where the sky is truly dark, where no other galaxies are visible, and where the evidence of the Big Bang has been stretched into oblivion. They might conclude that their single galaxy is the entire universe, alone in an infinite void. They will lack the clues we have today to understand their origins. We are privileged observers, living in a time of abundance. The fate of the universe is a reflection of the laws of physics that govern every breath we take. Gravity, electromagnetism, the strong and weak nuclear forces, these are the same tools that build a DNA molecule and destroy a star. The universe follows a script written in the language of mathematics, and while we are still learning to read that script, the ending seems clear. The universe is a one-way street. It moves from order to disorder, from heat to cold, from the crowded brilliance of the beginning to the lonely silence of the end. But there is a strange beauty in that finality. It gives weight to the present. If the universe were truly eternal and unchanging, our moment in time would lose its uniqueness. Because the universe is changing, because it is heading toward a conclusion, our existence becomes a rare and precious event. We are the flame that burns brightly in the middle of a long, dark night. The darkness was there before us, and it will be there after us, but that only makes the light more significant. We continue to search for answers. We build larger telescopes to see further back in time. We smash particles together in giant accelerators to recreate the conditions of the first microsecond of existence. We peer into the hearts of black holes through the lens of general relativity. Each discovery adds a sentence to the biography of the universe. We may never know for certain which ending is the true one. Dark energy might change its nature in ways we cannot predict. New physics might emerge that changes our understanding of entropy or gravity. But based on everything we know today, the universe is preparing for a long, quiet sleep. As the eons pass, the expansion will continue. The distance between the Milky Way and its neighbors will grow until the light can no longer bridge the gap. The stars will exhaust their hydrogen, then their helium, leaving behind cold cinders. The black holes will reign in the darkness, only to evaporate into nothingness. The very protons that make up the hearts of atoms might decay, causing matter itself to dissolve into radiation. The universe will become a vast, empty sea of low-energy photons, stretched to infinite wavelengths. And yet, in this very moment, there is light, there is heat, there is the complexity of the human brain, the most intricate structure we have ever found in the cosmos. We are here, now, in the vibrant heart of the story. The end of the universe is the final destination. But the journey is what matters. The journey from a single point of light to 100 billion galaxies, and finally to the quiet peace of the void. It is a story of epic proportions, and we are the ones who get to tell it. We are the witnesses to the grandeur of existence, the ones who look at the dying light of distant suns and understand what it means. We are the universe's consciousness. And as long as we are here, the darkness has not yet won. The stars are still shining. The universe is still awake. And we are here to see it all.